Good day everyone, I am Vishnupriya. I am pursuing my MTech from VIT Vellore in specialization in artificial intelligence and machine learning. Now my problem statement I am explaining, that is IoT real-time sensor diagnostic agent. And to tell about this agent, basically I'll take example of industry where we have multiple sensor fusions and multiple distributor systems which works on different sensors. If any damages occur due to faulty readings or any external damage, we should replace the whole thing. So we have to find it before in prior so that we can replace it at an earlier stage and reduce the cost. In case if it is a very poisonous thing like a gas leak or something, it might even endanger the human's life. So in these cases, to help us in finding the anomaly in a very early predictive stage, that is like a predictive maintenance, I'm using this agent for me to give us the diagnostic and detection with the root cause and recommendations. And this project is an AI-powered anomaly detection and diagnostic for IoT sensors, which we have built using LangGraph and GPT-4. Coming to the core tech stack, we are using orchestration layer, LLM integration, data processing, simulation, and logging. For orchestration, we are using LangGraph, which is a six-noded state machine workflow. For LLM integration, we are using LangChain plus OpenAI for the answering and decision making. Here it is used for root cause diagnosis and data processing using NumPy, and we are using some statistical anomaly detection like score, IQR, and so on. Simulation, we are using the Python random data simulation plus NumPy for pre-processing. This is used for realistic sensor data, which resembles the industrial data, and logging. Python for logging the data and for observability. And what are the six node pipelines which I am using is node 1 validate and fetch readings, detect anomalies for four statistical methods, LLM for diagnosis and root cause finding using GPT-4. That is where I got the OpenAI that API key for accessing the access severity, which is low, medium, high, or critical. Generate recommendation and action plan based on that, and execute the actions like giving alerts and creating the tickets for the users. And finally, we are getting the diagnostic report. The fourth detection, anomaly detection, what I am doing is that score, which is for extreme outlier detection, which is a very important statistical approach for finding the anomaly. Quarter IQR is a quarterly based where we take the difference of the third quarter, which is 75% minus the first quarter, which is 25% for the box plotter outliers. Then trend drift, that is the drift detection using linear regression, and rate of change for sudden jump in any data. And the combined score should be between 0 to 10, and if it is higher, it means it is worst. Now we can run this code in two ways. One is batch mode, and another one is like every 2 seconds getting the fetching the sensor data. That also we can do. Now I will be running the batch mode. Okay, I ran. You can see we are getting no anomaly. Severity is low, and some recommendation is generated. There is no anomaly. For 100% confidence, severity is low, and recommendation is just investigate on sensor labs and compare with other similar sensors. Estimated time it is giving and processing time it is giving, and it is getting stored here. Now the time is 15:05. We can see 15:04. What is happening on the node 1, 2, 3, 4, 5, 6. Here you can see the ranges, detecting anomaly, diagnosing root cause of the element generated. All these things is stored in the sensor log. Now, scenario one, normal temperature reading. It is like detecting success root cause, no anomaly, low. Okay, so it is showing no. Now for the for this is for the period of 2 seconds we can do this. And every 2 seconds the data will be stored in the um, log what happens and all. Then this is used for continuous monitoring. And for the scenario one, normal temperature, no anomaly, it will be shown like this. Anomaly detection, no, no anomalies, 100% confidence, no severity is low. And scenario two is we can anomaly detected. Yes, it's the 7.50 out of 10 found statistical outlier and sudden change. Root cause is environmental stress, something like that. It will give us. And we will go for scenario three, voltage drift, battery drying. Yes, 6.20, and it is giving a slope value of minus 0.15. Confidence score is 92, so it is less than 100. So replace the battery immediately. Check for power supplies, cost estimation, time estimation, and finally the log file looks like this when it is some anomaly details, LLM diagnostics, actions taken. You know. So this is how my whole project is, and basically why it is valuable. Now I will come for that because it is 24 into 7 diagnosis happening every time. For every 2 seconds also we can find like what happening for continuous data fetching, and accurate because we are using statistics, that is 4 statistical methods, and LLM GPT-4 for reasoning. Fast because it's 3.5 seconds per diagnosis, and scalable we can scale it with MQTT or REST APIs for getting the real IoT sensors or any other industrial sensors reading. We can directly get it, fetch it through MQTT or REST APIs and API like put, get, post, and all. We can scale with that, and we can fetch with live data, and it is actionable with cost plus time estimates, and performance is good. It is having 5 milliseconds, detects 50 milliseconds within that. LLM takes 3 to 5 seconds. And this is the code highlights. Like for LangGraph, what is the code we are using? Fetch, detect, then detect, diagnose. That is 6 steps we are taking for doing this: fetch, detect, diagnose, and give recommendation. For the detection logic of anomaly, we are using, as explained, that's called IQ, trend slope, and rate of change, sudden rate of change. For LLM, the initial temperature, we are giving 0 for deterministic output. For closing, I would like to tell LangGraph enables AI orchestration at enterprise levels, basically, so that we can use it in a lot of industries, not just industries like chemical industry or nuclear industry, nuclear power plant industry. It can be used in medical, it can be used in IoT, home automation, etc. By reducing your cost and making everything automated. And it is very much helpful in real-time IoT and saves hundreds of hours manually. And thank you for the opportunity.